it was just a worksheet that I had a key for, right? Or do I need to say it? Is there anything you have any questions on?
Oh shoot, we're not gonna have that periodic table tomorrow.
Not that one. You will have a periodic table tomorrow.
I just want, can we go over on like the gas notation, like how do we know where to start? I
Okay.
kind of got it, but I
Here's how we know where to start. Say we're doing selenium, Tc. Okay, we would go up and we would find krypton, correct?
Yeah.
Okay. Remember, the noble gases are abbreviating a whole bunch of stuff, correct?
Yeah, I just don't know
Okay,
where
so I'm
those fall in.
abbreviating everything up to the 36th electron. Does that make sense? So I need to figure out what is the orbital and the energy level that krypton will completely fill. And so it's in the 4th energy level. It completely fills the P, right? Because it's at the end of the P. So you would start after 4P.
Okay.
Does that make sense?
And then,
All your noble gas notations should start with an S, because all of them end with a complete P.
okay.
Yep.
All right, that makes more sense. All right, we're good. Okay.
All right. I think this is the last section of this chapter. So we got 2 days on this. Well, 2.5 days if you want to call this a 1.5 day. What we're going to be talking about is isotopes, and then we are going to be dealing with those top left corner numbers, atomic mass units, like I started to kind of introduce the other day. All right. Now, who can tell me? Anybody remember what an isotope is?
Isotope
It's
is
a
a
charge, well,
No,
it's
it's
a
a
different
atom
number
has
of
less
neutrons.
neutron, less or more.
Less or more neutrons. Yeah. Okay. Different number of neutrons is an isotope. Okay. But let's just quickly review some things. What does the symbol Z represent?
The atomic.
The atomic number, and what is the atomic number?
The number of
Protons.
protons.
Number of protons. Okay. And where do you find the Z?
The red.
The red.
The red numbers, and it tells you the number of protons, but also kind of indirectly tells you what?
Electrons.
Electrons, okay, because it has to be the same because the atom is what?
Neutral.
Neutral, okay? And so then, like for chlorine, I got 17 protons and 17 electrons and 17 neutrons. We don't know that. We can't assume that it has the same number of neutrons, and we'll talk about that here in a bit. Other things. I probably don't need to do this. Probably don't need to ask you what's in the atom and where they're located. You guys already got all that stuff down, right? Hope. Okay? So here's what happened. We haven't really talked about Chadwick much. You guys read about Mr. Chadwick? Chadwich? I kind of like to say that. Chadwich.
We learned from him.
Okay? After Chadwich discovered that the nucleus had protons in it, there was still something that puzzled them. Okay? When they ionized atoms in a single gaseous element, when they were shot between electrically charged plates, the electrostatic force deflected atoms. What he noticed was that the same atom, so like essentially what they did is they charged an atom, they shot them kind of like a cathode ray. You guys remember that? Okay, but instead of just shooting electrons, they shot charged particles. And the reason why they shot charged particles, or ions, was because they wanted to be attracted to a plate, a charged plate. So just imagine taking some source and shooting charged particles through, between a positive plate, and a negative plate. And they're shooting straight through here. All right. The reason why it needed to be charged is so that it could figure out how they would interact with the two charged plates. Because if it was a neutral atom, what would it just do? Go straight through. Okay. And so what they did is they charged a whole bunch of, I don't know what the element was. Let's say they charged a whole bunch of nitrogen atoms. Okay. Or a bunch of nitrogen ions. And they started shooting those nitrogen ions through these plates, and they noticed that they bent and they curved. Like they should, right? They bent towards the side it was attracted to and away from the side it wasn't. That should make sense, correct? Now, if all of the atoms of the nitrogen that they shot through there were exactly the same, which is what they would have thought, they all would have bent how? If all the nitrogen atoms, if we assume that every nitrogen atom is exactly the same, and we shoot them through here, yes, they're going to bend, but we would assume that they would all bend how? The same way, right? Because they're all the same mass, they all have the same charge, they're going to bend exactly the same way. But they didn't. Okay? Most of them, a lot of them bent a specific way, but there was a few small percentage of these guys that were bent a little bit more and a little bit less. And that puzzled Mr. Chadwick. Okay? Essentially, what he realized is that all nitrogen atoms didn't have the same mass. Well, why in the world would all these nitrogen atoms not have the same mass? We know that they have to have a certain number of protons, a certain number of electrons, and they have to equal each other out to be a neutral atom, right? So, yeah. And this is what.
But can you tell me how they're shooting particles?
Not easily, no.
How do they like nitrogen?
Yeah, I know what you're saying. I don't really 100% even know. I haven't had that question. I guess maybe I'm not, curious enough like you are. Which I think it's a good thing that you're curious enough about that, but like I never really thought, how does this work? I mean, you can look it up, figure it out. I just haven't done that. Is it interesting? I probably should have, but it's just not something I've done. So, fortunately, I can't answer that question. All right. Where was I? Oh, different masses. Okay, and I can't remember if this was before I think this is how they discovered the neutrons. Was that they realized there was something in the atom that was independent of charge that had a direct correlation to the mass. And that's how the introduction of neutrons came into play, and that's where we ended up getting our things known as isotopes. All right, you should. This is not a negative sign. I need to change that. I'm going to do that now. Every time.
Say, why is it negative?
It's a dash. Let's see. Let's change that to a arrow. That better? Or should it be a bullet?
Well, change the other one too.
Bullets are better than arrows.
I like arrows though.
But there's already bullets on the other thing.
Square?
You just change it to something different.
Stop.
Dude, there are bullets on all of them except. Sure, that's good.
Space.
Yeah. Oh yeah. Oh, cool. We'll do that. Okay. Square A.
Once we learn it, just.
Square A equals Z plus S. Okay. So we should remember what Z is. Yeah. What is it?
The red numbers, so like.
Atomic number, which is the
No, red number.
protons. Yeah. What do you think N represents?
Neutron.
Ah.
Ooh.
I probably spelled neutrons wrong.
Neutron.
I always.
N-E.
Is it? Gosh, I've been doing this for so long, and I still.
Like neutral and EU.
Neutron.
Neutron.
It's like the U could be a W neutron, but it's not.
Okay. Na. Now this is something I hit on a lot in physical science. If you remember, mass number. Do you remember
Oh,
where we added? If we know the number of protons, we know the mass number. We can figure out the neutrons. If we know the neutrons and the protons, we can figure out the mass number. Okay, we did isotopes in physical science. This is important. Depends on whether or not you were a crammer or whether you were just in desired learning.
Or
And
okay, or
wanted
you
to-
were both.
Grammar or a grammar?
Okay.
Yes, you can.
Notice how no one laughed.
So you're saying you can care but still cram?
Yes. If you don't have time to study, like you still care about learning, you still learn shit. Just-
All right.
Okay.
So atoms with the same number of protons but differing number of neutrons are isotopes. Chadwick realized this when he started to see how these particles were not bending the same way, because they would have bent the same way if they all had the same, if they all were made up of the exact same stuff, which they weren't. Okay? So, if I ask you this question. Carbon. A particular carbon atom has 8 neutrons. Tell me the math.
14.
What? Last.
Oh, because plus 6, 8 plus 6 is 14.
Why did you go, oh, okay.
They didn't let anybody else think. It was a rhetorical question.
Okay, sorry.
Okay, everyone look.
Just rhetorically.
Figure out is 14, why is 14 the right answer?
Because carbon 6.
Okay,
And
so
plus
what
eight.
carbon 6, great, carbon is 6. What does that mean? Carbon 6
protons.
6 protons,
6
6 electrons.
protons, okay, and if I want to find mass number, by definition, mass number
Is proton plus neutron.
is protons plus neutrons. So if I know the number of neutrons, we always know the number of protons for a particular guy, right?
It'll have to give you the number of neutrons, right? Well, there's a couple.
They have to give you something, yes. Okay? What's another equipment?
Is it just a coincidence that right above it, the carbon is 14?
That's just coincidence. That's group work.
So
Yeah. Okay? So it's still pretty easy. Like if you think about it, you know the protons always. They either have to give you mass number, that you can find neutrons, or they can give you neutrons, you can find mass number. That makes sense? Just simply adding or subtracting. Okay? What if I did this? What if I said, you got a mass number of 23, and you've got you've got 11 neutrons. What element is it? Yeah.
Canadians, when they ask
minus
rhetorical
11.
questions, they say A. Should we just do that?
Okay, remember, I asked what element it is, and remember there's one thing that determines identity. Do you remember what determines identity?
A.
The protons always determine the identity. And what did I do? I gave you the mass number, A, and I gave you the neutrons,
B.
11, or N. Could you subtract 11 from the mass number to get Z, which is the atomic number or the number of protons, which determines the what?
Oh, yeah.
The identity. Okay, so if you take your 23 minus 11, you got 12 protons. It cannot be anything else but magnesium. There's no other guy that has 12 protons. Okay, does that make sense? Are you starting to see the questions I could potentially ask you on a quiz or a test? Okay?
Makes sense.
Yeah.
Alrighty. Alright, here's another form that you might see these isotopes in. Okay? If you see in the form of an element with a hyphen followed by a number, what that is, this number is always the mass number. So if I'm looking at this, I know it's oxygen, I know my mass number. Could I determine how many neutrons it has?
Yes, A.
Now I wrote that, it's up there, it says, but remember, if I know the element, I automatically know one thing. What is it?
Proton.
Protons, okay? You would look at the periodic table, you would find oxygen, you would see it has 8 protons. Guys, this isn't difficult outside of the fact that you gotta be familiar with the vocab word I'm using, mass number, atomic number, things like that, and know how they relate. By definition, mass number is protons plus neutrons. That's what it is. Okay? And then you gotta know that this number here, or the one after the hyphen, is the mass number. Once you know that, can you add and subtract? Yeah. Most of the time. Sometimes it's hard. Okay. So, 8 protons, 8 neutrons, How many electrons?
8.
8. Why 8? Is it just a coincidence that they're all the same?
Because it's not an ion.
It's gonna have the same amount of electrons.
Yes, why?
So
Just
it's
'cause?
neutral.
I don't know.
To be balanced, so it's
To be neutral, right? Atoms are neutral, they have no charge, and if I have 8 positively charged things, I need to have
8
8
negative.
negatively charged things. Does that make sense? What if I was saying an ion? Ooh, let me ask you this one.
Oh, no, are you gonna make us do ions?
Sure, why not?
Here we go, I got this.
Oh, there's a little dot.
Let's say I have a calcium 2 plus ion.
Okay. What is the 2 plus mean?
Electrons.
It
No, the 2
it
plus?
lost 2 electrons.
I'll let you decide.
I figured, yeah.
Did it lose 2 electrons?
That's Monday.
You actually don't, this isn't even as hard as I thought. Darn it. Alright, let's say mass number is 42. Tell me protons, electrons, and neutrons. Go.
The proton?
Don't say it out loud.
What did one
You just said
ion say
go.
to another? I've got my ion.
Nice picture.
No,
So hard inside.
I think chemistry puns. When you do chemistry puns, you're in your element.
Oh, I just need to get a whole bunch of chemistry puns and add say one every day.
No,
Yes.
All the girls are like, please no. Hey,
Wanna hear a chemistry pun about salt?
you think you got this?
Nah.
Wait a second. What is 42?
Come on.
Oh,
Are some of you even trying?
yeah.
Again, I like to try to throw some of these more difficult ones out at you so that you can
Oh, yeah.
think a little critical.
No.
Critically.
With the defense.
Oh!
Going in.
Was it?
Yeah.
Yeah.
I tried to pop it.
It did kind of look like it.
Alright, protons should be easy. Answer is?
20.
Other two are not quite as easy.
It's
Neutrons are probably the next easiest.
22.
22, why?
Because you have to subtract 42.
2
I mean,
minus
20 from
20.
These two should add up to get the mass number, right?
Yeah.
Electrons now.
18.
Because it's positive twice, because it is,
So you-
has
We
lost.
got 18
Shout out,
negatives,
Marvin.
20 positives. There's my positive 2 charge.
See, I knew it. It was really
That makes sense, everybody?
You taught us that last.
Brevin?
Yeah. I remember it since I
No.
thought about it.
I don't get this.
Shout out course
I love this stuff. This is so fun.
How did this?
So what is it that you aren't getting? Can you articulate? You know how to figure out the protons?
Why did we do an ion?
Why? That's not a question that has anything to do with how to do it. You just asked why did I give it to you? I gave it to you because I want you to think outside the box and actually do something that is not like super easy all the time. Okay? Quillen, is that making sense now? You look at it?
Just add the 2 to the neutrons and subtract.
Did I what? Sorry.
Just add the 2 to the neutrons and subtract the 42.
And what?
Add 2 to neutrons on there, so there's 24 and 42.
No. Nope. So this one was easy because we know it on the periodic table. This one you can figure out by taking the protons from the mass number.
How do you get the electrons?
Okay? The electrons had to do with the fact that it's
It
a
lost
ion.
two things.
So this is saying this guy has a positive 2 charge. What that means is either one of two things, and one of them's wrong. It either has 2 more protons, which that's wrong, because if it gained 2 protons, would it be calcium anymore?
No.
No, does that make sense?
Yeah.
Okay? The only other option could be, it could have lost 2 of its electrons to become positively charged.
Oh, I'm
How
often do I tell jokes about
So-
chemistry?
Does that make sense?
Periodically.
So what I did is I looked at this and I said, it's got a positive 2 charge. I know I have 20 positive things, so I have to have 18 negatives to have a net of 2 positive charge.
Yeah.
How often do I tell jokes about chemistry?
Is this another joke?
Periodically.
Periodically, do you know what periodically means?
From time to time.
Repeatable.
You know, I just figured this out. Chronos means moment. So
We had a chrono.
Chronos is the Greek
Alright.
word for time. So chronological.
Okay, we're gonna end with isotopic notation here. Let's finish, please. Let's finish. Isotopic notation, then we'll be done. Okay? We did this last year, or 2 years ago, if you are a junior. Okay, a naming convention that is used to name isotopes. Okay? Here's how it looks. Let's say I have a carbon 14 atom. Remember, what does that number represent in that form?
The mass number. So we have.
Okay? So here's how isotopic notation goes. First thing you do, and I think, do you have a space for this? Yeah, it says carbon 14, doesn't it, right there? Okay? Here's how this works. You always have the symbol of the element that you are writing the isotopic notation for. So carbon symbol is C. Then it says leading subscript and leading superscript. Leading just means before, not after.
Oh, superscript.
Subscript is a what?
At the bottom.
At the bottom, and a superscript is
At the top.
at the top, or an exponent. But remember, it's not after, it's before. And so I put the atomic number as the leading subscript, or right here. Do we know the atomic number of carbon?
Yes.
If I know any element, I should be able to determine what the atomic number is by looking at the periodic table. Okay? The leading superscript is what?
The mass number.
The mass number, which they gave it to us, 14. I'm telling you now, there's your mass number.
Not leading.
There's your atomic number. Now you have all the information from this to be able to tell me how many protons, electrons, and neutrons you have. If you have isotopic notation, you should be able to answer all of those questions, assuming you're talking about an atom. Unless they told you, you could do it if they told you it was an ion and told you the charge.
This is why I like chemistry a lot better than physics.
Why?
I don't know. I enjoy this stuff, but this
electrons at all.
Yeah, it does. There's 6.
They could be 7 though.
If I showed a charge.
Like if it
Oh, you
was
have to
7.
show-
Yeah, I'd have to show a charge.
So if it was 7, it would be like 14.6C minus whatever. However many.
It would still be 14 over 6. You just, if you want to find the number of electrons, if it's a -1 charge, you add another electron to get the charge.
Where would you put that?
You wouldn't write it in there. You wouldn't write that. That is all you would do for isotopic notation.
Okay.
If I asked you that question, you would write it in somewhere else.
So that could, for all we know, that could have.
It could. We don't know. Well, okay. I will say this. I'm not going to, for isotopic notation, ever do a charge atom. Okay. Okay? So here's what I want you guys to do here. I want you to do the isotopic notation for these 3. Not too hard if you know what those numbers after the hyphen represent and how the format of isotopic notation works.
What's the symbol for uranium?
U.
U.
It'd be like 92 or something like that. Yep, there it is. Way at the bottom.
Good night, Wed.
Come on, bum. Bummy, bummy, bummy.
82, what is 208 minus 85?
85.
Or
208 minus 80 would be 128. Minus 2 would be 126.
This was a big day.
Oh, U is at the
Holy
bottom.
moly.
It's uranium too.
Wait.
At the bottom. Or is it like IN or something?
I thought it was mass number.
The atomic number is the leading.
Yeah, the mass number. 38 mass number.
I don't know.
Oh.
Yeah.
I don't know.
I don't remember.
Why they use the mass number as say, I do not know.
Just let me know.
No.
Like,
Lead
neutral is N.
PB. Ah, shit! I'd taken physical science. Know that. Everyone would have known that, right? Bumming from your bumming, right?
Is uranium you, or is it like you?
It's
I know
you.
about
Oh,
It doesn't worry
hydrogen,
about it.
helium, and carbon and oxygen.
But don't.
That's orange. And bromine.
Okay.
That's all I
We
got.
got 1 minute, so I want to see how we're doing here. Your sodium symbol,
And then
mass number,
406.
and atomic number. Okay? Lead. Mass number is 82, right?
Yep.
And then they gave us 208. And then uranium's mass number is 92. Notice something. The top number will always be what?
Bigger. Now I
Because it's
remember
protons and neutrons.
Now I remember.
Now, last thing, I want to make sure you put this in. So I want this in your notes, guys. I'm seeing a lot of students that aren't filling out their notes, and that's a problem. Okay? So here, the just wants to ask, how many neutrons do you have? If it's in these form, it's really easy. What do you do?
Subtract them.
Trash.
Subtract the bottom from the top.
13, 126.
Because isn't this protons and neutrons?
Yeah.
And this is protons. If you take the protons away from the thing that has protons and neutrons, you're left with neutrons. So sodium has 13. Lead, I can't, 126.
That's how that
We have
works.
homework. Yeah, we
no.
worksheet.
No.
Wait, the thing's in Oh, yeah.
And uranium should be 143.
Oh, yeah.
143.
What we're doing, atomic mass.
I didn't make it into this early video.
I don't really remember that.
Well, actually,
Isotopic notation. You don't remember anything? All that A's you got in my class, and you don't remember those guys? What is this about? The failed academic situation.
All I remember is
I never got the name of one thing.
But you know.
I said atomic instead of isotopic.
Oh, okay.
Yeah, don't you have to use the atomic number in it?
Ethan, you're wrong.
There's the same number of.
I was hoping I could have you when I was hoping that like if I missed a day, I could just have you come teach.
It's always right
That's what I was hoping. But now you just I was hoping. We can collaborate.
Dude, we can all teach. Yeah, let us do it. Oh my goodness.
If you gave me your teacher guide, I could probably do it. I'd just be like,
Oh yeah, sorry. Can we take physical science next year?
No, can we take
all 4 of your classes next year? Physics.
Yeah, right.
I'll be okay with just
You guys have so much homework. I mean, I guess you guys would know how to do it.
Yeah, exactly. It would take like 5 seconds.
Keep all of your
I
homework.
still don't know how to do that.
Math is that.
Isn't this just sugar?
Yeah. Oh, yeah.
Sucrose.
Nah.
Right, it's literally so good.
This is 1 mole.
Yeah.
I'm right.
Not exactly, because some of them are on.
You just do the
We do the hole that's
Never
on
on
the side.
panel.
After you. Just
That's
kidding.
why the ocean has so much salt.
How long was that? Like, you won't last.
Is it just me or is it
How many was that? Quail.
Are they laughing at us, Patrick? Or are they laughing? No, Patrick.
Alright, there's a bell ringer, and the bell has rung.
No, they haven't.
Oh, I will.
Never rings.
No, that's 2 minutes before, so has the bell
It's
ever
still,
rung?
the bell has
This Stoker let us out late.
year.
We're still on the rung.
We're still stuck on the first song.
What?
Friends, what is a bell?
Bells are mostly bells.
A dog called a
It's a thing that dances with a beast.
Did you just
Alright.
rectify a woman?
Yes.
That's not our bell.
Alright, there we go. Bell ring. Bell ring.
When did I go to?
How long did you find that, like, empty?
I just looked it up.
I literally just looked at that.
Literally.
Alright, there you go.
Why is my name like?
This is come over Tiger. They're up.
No, it's not.
Yeah, it is.
Sokotoa.
But like,
That's the same thing.
Sokoto.
In my head, it's the same
thing.
It's the same principle.
Guys, today's lesson's easy.
Wait, really?
I've been thinking about it.
It's the Fermat equation.
First of all,
You don't remember the Fermat equation?
Forcing
remember
acceleration.
F equals
Just this
mx.
year?
Because I hated chemistry last year and I was disappointing myself constantly, so I just didn't like the class.
Yeah, that kind of, that's fine.
I think it's
View of the
always
teacher,
teacher's
great.
just a
Now
gas.
everyone hates me because I teach the classes that nobody likes.
No, I like you.
Oh no, trust me,
you
you're the reason I
challenge
look
people.
forward.
Yeah, you don't let us slack off, and that's what I don't like. I
Wow.
don't like having to work for an A.
No, I'm just kidding.
Wow, that is
Like
like
self for all my tests.
Bring back fish. Bring back fish.
Actually, I got a 97 on the test yesterday, so things are going not bad.
it works.
Did you know they do not know the atomic kernel? They don't know the science.
I would not believe they would.
That's what we need.
It's so radioactive that
Isn't even on the.
they don't know the electric first. We talk about first
I can't
ionization
find my
energy.
notes active.
Yeah, that's what we, it has.
That's second ionization
Like when you saw it, you think she looks.
and third.
Don't think it was third.
Thank you. I have 3 people.
I hate those calculators. They're like Satan's cousin. You hold up your phone, you got Satan. You hold up that calculator, you got Satan's cousin. Right?
Oh, do you remember from fun being
That's what my notes said. Just drag a line. I just noticed.
Where's the favorite card?
3 of them said that.
42.
Yeah.
Just like right in
Sorry.
Nice to meet you.
It's actually a probability.
Didn't you say it actually worked?
Yeah, I did actually work on some Serenity.
All the dog cards.
Homework out. Hey, homework out while you're doing this.
So cool.
And if you didn't do the stuff yesterday, hopefully you have it finished.
You have a long time when you got
But Jesse, what was 11 feet? I never actually.
that. So review that.
There's also a 6 calculator.
Oh, that's what I did.
Big calculator on that thing?
Yeah, that's
I'm gonna die.
Who has
Do not tell my younger students.
What?
Do not. That's trash.
That's well,
Like physical science wouldn't happen
No,
because
you can do it.
I got like 7 kids that don't even
Yeah,
have
you
it.
can go search on the internet how to do sig fish.
I'm sure it's a way to do it on
I
that.
was actually just about to show Benjamin.
Okay, bet. Well, now we can't.
Oh.
And then I was like, no, actually,
No more calculators, you gotta use your hand.
Yeah, let's do it.
How do you
I don't know if
use
you
your
saw mine,
hand?
but
Did you see my Instagram?
These guys. I don't understand.
No, sorry.
Oh, it's not going to be a scientific application if that's not it.
This?
But all calculators.
Yeah, you do 20 minutes on the next one, too. Oh, wait, there's a vector.
What do you know?
I think you're right. Goodness me, the people who are on the
Oh, you put Jesse. That would be an
Did you hear that?
Oh, I'm exaggerating. You pulling from a rope?
Yes, sir. Different direction.
No! No!
If you don't go first.
Back to the calculator.
Shut up!
I did it all right.
We're not gonna use it no matter what.